So today topic and which I would like to discuss about the wet or electrochemical corrosion. Wet corrosion, the name itself indicates this type of corrosion usually takes place in the presence of moisture. And here the wet corrosion is also called as an electrochemical corrosion. The reasons for why we call the wet corrosion as an electrochemical corrosion is one thing is when the conducting medium is in contact with the metal, and the other reason is when two dissimilar metals are connected together and are exposed to the conducting medium. So these are the two reasons for why we call and wet corrosion as an electrochemical corrosion. So here, once the electrochemical corrosion is being taking place once the electrochemical cell is being formed, we know that there are two regions in an electrochemical cell, anodic region as well as cathodic region. In case of anodic region, the oxidation takes place by the liberation of free electrons, whereas in the cathodic region, the reduction takes place by consuming the electrons. So in the cathodic region, they consume the electrons either by the evolution of hydrogen gas or absorption of oxygen. So the first one, evolution of hydrogen gas. For the evolution of hydrogen gas, here, if you observe this particular diagram, I've taken a particular iron metal and iron metal being exposed to the acidic medium containing HCl solution. So the acidic medium which I've taken here is HCl solution. So one thing, the rate of corrosion would be faster in acidic medium rather than that of the basic and neutral medium. So the iron metal, when it is exposed to the acidic medium, faster will be the rate of corrosion. Immediately the iron metal undergoes oxidation, liberating Fe+2 ions as well as electrons being liberated. So here, these liberated electrons tends to react with the H plus ions of the acid, producing H2 gas. So in this way, the hydrogen gas is being liberated. One thing which we need to remember here is, in case of liberation of hydrogen gas, the anodic area is large and cathodic area is small. Why the anodic area is being large means, as I said you, the rate of corrosion would be faster in acidic medium. So as soon as a metal being exposed to the acidic medium, the entire metal which is being exposed to the acidic solution, that area tends to behave as an anode. So the unaffected area tends to behave as an cathode. So that is the reason why we find a large anodic area and a small cathodic area in case of liberation of hydrogen gas. The next thing, as I said you, in case of wet corrosion, they consume the cathodic area, they consume the electrons either by the liberation of hydrogen gas and absorption of oxygen. So the previous topic which I explained was about the evolution of hydrogen gas. The next one comes the mechanism by the wet corrosion by the absorption of oxygen. So here what we are doing is we have taken an iron metal and that iron metal is being exposed to the atmospheric odor. So here as soon as a metal, when it is exposed to the atmospheric O2, the surface area of a metal which is being exposed, there the corrosion takes place. There itself the oxidation takes place. It's not like that, like entire metal as soon as being exposed to the atmospheric O2, entire metal gets corroded immediately. So as soon as a metal, when it is exposed to the atmospheric O2, the surface of the surface area, the surface of a metal which is being exposed to the atmospheric O2, that surface area undergoes oxidation. There, the metal oxide layer being formed on the surface of this metal oxide layer. So here, as soon as a metal being exposed to the atmospheric O2, metal undergoes oxidation, liberating Fe+2 ions and electrons. Those liberated electrons tends to react with the oxygen, forming hydroxyl ions. OH minus ions are being produced. So this OH minus ions which are produced, those again tends to react with Fe+2 forming ferrous hydroxide. The ferrous hydroxide is a rust product which is formed on a surface of a metal. So here, as a corrosion is taking place upon the metal, wherever the part which is being exposed to the atmospheric O2, so there itself the rust will be formed. So these are, here we can observe there are few areas where the rust is being formed. Okay, it means these areas are being exposed to the atmospheric O2. So the surface area is being exposed to the atmospheric O2. There itself the rust will be formed. There only the metal oxide layer is being formed. So in case of mechanism of wet corrosion by the absorption of oxygen, in this case we generally absorb a large cathodic area and a small anodic area. Large and cathodic area, large cathodic area. Why we find a large cathodic area means, as I said you, as soon as a metal being exposed to the atmospheric O2, only the surface part which is being exposed that undergoes corrosion. The remaining leftover part of a metal that tends to behave as a cathode. So that's the reason why we find a large cathodic area, and the areas which remains affected, it means the areas where the rust is being formed, those areas act as a small anodic area. So these are the small anodic areas which are formed on the surface of a